Hi, everyone. I'm really happy to see you all from the screen today and excited to talk to you about text. And I'm sorry I couldn't be with you in person. So a little bit about me. My name is Natalia, and I'm a software engineer. I live in New Zealand. I've been working in web and mobile development for about 6 years, and I've been using SwiftUI since it was released back in 2019. I joined New Coalescing, it's the company I work at the moment, as a co-founder in April this year. And before that, I was working as a frameworks engineer on the SwiftUI team at Apple. And one of the areas of the framework that I was focusing on during my time at Apple was text. It's a deceptively basic component that can be tricky to understand at times. And today I would like to talk to you about how text actually works in SwiftUI and give you some tips on how to use it to its full potential in your applications. And I hope to get you excited about this simple yet powerful component. We're going to see how text behaves in different contexts and how the choice of an initializer affects the end result. We'll dive deeper into the functionality of the localized string key type, learn how it differs from regular strings, and why it's one of the core parts of the SwiftUI Text APIs. We'll see when and how text can parse markdown strings, which could help us localize rich text more easily. We will also learn how to work with text modifiers and view modifiers that affect text rendering. We will see why it's important to understand the difference between text and view modifiers to avoid some common mistakes. And finally, we're going to look into the attributed string APIs and learn how to use them in SwiftUI. We will see how attributes from different scopes are treated by the SwiftUI text view and why sometimes you might be getting unexpected results when integrating attributed strings in text. It's worth pointing out that text APIs in SwiftUI are mostly the same on all of the Apple platforms. So you can apply this knowledge on iOS, macOS, Watch, and even TV. When we talk about text in SwiftUI, we might just think about the text view that we create explicitly to show non-editable text to the user. But actually, many of the built-in SwiftUI components include text too. When we initialize common views and controls that come with the framework, we have to provide a label view, a string, or a string literal. Passing a string is just a convenience for creating a text label for the control. We have to think about these labels like we think about text views because it's what they actually are in the end. Styling and localization techniques that apply to standalone text views apply to control labels too. So what is text in the SwiftUI framework? Text is a view that we can place into a SwiftUI view hierarchy to display plain strings or rich text to the users. Text is a struct like all the other views in SwiftUI. It stores some information internally and resolves that information into a string at render time. The end result that the user sees depends on how we create the text and what context it appears in. Let's look at an example where we initialize a text view with a string literal. At this point, we don't know what kind of string this text will get resolved into because it's not added to the view hierarchy yet. To become a string that is rendered on screen, text needs to have an environment. Part of the environment may be defined by us, the developers, by applying view modifiers and setting environment values. The SwiftUI framework itself can also set an environment for the text, depending on where it is placed. The context can be coming from the user device settings too, like light and dark mode, accessibility text sizes, or device locale. Here we're placing the greeting text that we created earlier into a VStack and setting a purple foreground color on the entire view hierarchy. Since the greeting text is a child of the VStack, it inherits its environment, including the color. On the screenshot, we can see that the final string that gets rendered is purple. If we place the same greeting text in a different context, such as inside the link, for example, SwiftUI will style it with the appropriate link color. The framework is aware of the surrounding environment of the text, and it takes that environment into consideration when resolving the text into a string. Our greeting text, created with a string literal, can even get resolved into a completely different string. For example, it could be localized based on the device language if we are providing the matching translations in our bundle. We're going to talk about localization more in just a moment. So far, we know that the text struct stores some data and it resolves it into a string at render time. We can influence what type of data it stores and in what form, which in turn affects what string we get in the end by choosing the right initializer when creating the text. Text can be created with a string literal or a string variable, a date with a style or a format style, an image, an attributed string, and more. It's important to have a good understanding of all the available options to be able to choose the right one based on our needs and not to get unexpected results. Probably one of the most subtle differences, but a really important one, is between creating a text view from a string variable versus a string literal. In the first example, we define a string first, then we pass the string to the text view. In the second example, we are writing the string literal directly inside text. These two examples are not the same at all. SwiftUI will call two different initializers for these text views. When we create a text view with a string variable, the framework calls the generic initializer that accepts a value conforming to string protocol. This means that the data we're passing to text will be stored as a regular Swift string. When we create a text view with a string literal, SwiftUI calls the initializer that accepts a localized string key. That happens because the localized string key type conforms to expressible by string literal protocol, and because this initializer takes priority if there is a conflict. In this case, the data will be stored as a localized string key internally. SwiftUI is trying to be smart and assume that if we have a string literal in the app, we likely want to localize it. We do have a way to opt out by using the verbatim initializer instead. Sometimes these two initializers can actually produce the same result. For example, if we don't provide any localizable strings files, text created with localized string key will just display the key. So the users would see the hello string in both cases. The same result will also be produced if the localization for the key is the same as the string variable provided in the first example, like when English is set as a system language on the device. If the system language of the device is set to something like Italian, and we're providing an Italian translation for hello key in the localizable strings files, then the resulting string for these two examples will be different. The text created with a string variable will not be localized into Italian, while the text created with a string literal will be. The path to resolve the data from the text struct into a string that can be rendered on screen is different for text that stores a string and text that stores a localized string key. In the first example, the framework won't be trying to search for localization in the bundle, while in the second case, it will. That's why it's important to pick the right constructor for the right purpose. In case we do need to define the string outside of the text view, but still want to localize it, we can explicitly wrap the string into a localized string key and force SwiftUI to call the localized string key initializer instead. Let's look at another example when creating text with a string variable and creating text with a string literal yields different results. Sometimes we might want to interpolate an image into the string we pass to text. In the first case, we are defining a string and interpolating an image outside of the text view. In the second case, we are creating a string literal with interpolation directly inside the text initializer. The string outside of the text view will get initialized with the default string interpolation, which appends the image description to the string. The literal inside of the text view initializer will get implicitly converted into a localized string key and will use the localized string key string interpolation API instead. This appends an actual image to the string. There is another case when a string variable and a string literal will result in different outputs. When we initialize the text with a localized string key, SwiftUI will try to parse Markdown from that string at render time. This doesn't happen when text is created with a regular string. We can see that in the first example, we are defining a string with Markdown syntax and then passing it to text. The string output of that text is the exact string we provided, which includes Markdown markers. In the second example, text gets initialized with a localized string key that contains Markdown. It gets parsed, and the output is a styled text with the bold text font, where we place the strong emphasis. Note that if Markdown is not valid, SwiftUI will fall back to displaying the original string. It will not produce an error. If for any reason your string literal contains valid Markdown syntax that you don't want to parse, you can use the verbatim text initializer. If you still want that string localized, you would need to localize it outside of the text view using one of the foundation localization APIs. Just the same as with localization, we can force SwiftUI to treat our string variable as a localized string key and parse Markdown by wrapping the string into the localized string key constructor. The result we see here is a styled text with bold font in place of the strong emphasis markers. Localized string key provides a lot of functionality to text views. Apart from localization and Markdown parsing, it supports many interpolation options, which let us include images and dates, as well as display rich text with attributed strings or text modifiers. It supports appending multiple different types and even lets us nest text views within each other. There are some interesting things that we can achieve by leveraging the power of the localized string key string interpolation. For example, we can create text with dynamic dates that update live automatically. When we interpolate a date, we can specify a style. If we use relative, offset, or timer styles, SwiftUI will show the difference between now and the date we provided and update it in real time. This works in widgets too. To display dynamic dates in widgets, we don't need to update the timeline. We can simply interpolate a date inside the text view and indicate the appropriate style for the date. By the way, the video and the time left until the Apple event is not real here because I filmed the video in advance. So nesting text views is another interesting use case for localized string key string interpolation. We can style different portions of the string with different text modifiers. For example, we can see that the outer text doesn't have any modifiers applied, so it's rendered with default styling, while the inner text view that says SwiftUI has purple foreground color. There are actually multiple ways to style portions of a string in SwiftUI. Apart from interpolation, we can also use text concatenation by adding a plus sign between the text views. Text views connected with a plus sign get merged into one string in the end, but it gives us an opportunity to apply different text modifiers to different substrings. Be aware, though, that text interpolation is preferred over text concatenation, especially for localized strings. Text interpolation keeps the order of the words flexible so that it's more appropriate for different language where the order of the words in the sentence doesn't match the original one. When we use text interpolation, we can only apply text modifiers to the inner text views. Text modifiers are modifiers that apply to the target directly and return a text. There are a few such modifiers in SwiftUI, like bold, italic, foreground color, underline, etc. In our example, we are interpolating a text that says world and applying the bold modifier to it. It creates a modified text view with the bold font modifier, but it is still a text view type. That's why it works inside of another text view. As of iOS 16, all of the text modifiers have equivalent view modifiers that can be applied higher up in the hierarchy and affect multiple text views at once. View modifiers that affect text set a value in the view hierarchy instead of applying the modification to the target directly. They return some view, not text. Such modifiers can be set on any container view, and their values will flow down to child text views. Remember I said earlier that labels of different SwiftUI controls, such as buttons, for example, are also text labels. That means that these types of modifiers affect them too. In our example, the text and the button in the VStack will get all of the styles from modifiers applied. Some view modifiers, such as text case, line limit, and minimum scale factor in our example, don't have equivalent text modifiers. That means that we can't use them with text interpolation. When they applied to text view, they convert the text to some view type. If we try to interpolate some view, we will get a build error. And that type of error was quite cryptic before, and it was difficult to understand what was wrong when we tried to interpolate a wrong type within text. The error improved in iOS 16, and it now points us to the supported types. We can override styles set higher up in the hierarchy by applying modifiers further down. Styles applied within text interpolation take priority over styles applied outside of the text view. In the first example we see on screen, we're applying the bold modifier on the stack. We are overriding the bold weight by setting font weight regular on the first text of the VStack. Inside of the first text, we are overriding the font weight once more on a portion of the string and set the weight to thin. Apart from overriding styles, we can also reset styles to default values. In the second example, the foreground color is set to purple on the VStack, but is reset to the default text color on the first text view in the stack because we are providing a nil value to the foreground color modifier. This will make the first text in the VStack behave like foreground color was never set at all. And the text might take standard label color or whatever other color SwiftUI decides is appropriate for the text in the current context. Another way to style portions of text in SwiftUI, which gives us a lot of customization options, is to use the attributed string APIs. Attributed string was introduced in Foundation a year ago, and it provides Swift-based APIs for dealing with characters and attributes similar to the old NS attributed string, but strictly typed instead. Or we can define an attributed string and pass it to the SwiftUI Text view to display. For example, we might assign a background color to a substring, and SwiftUI will style the text appropriately. Attributes for the attributed string are organized in different scopes. Each UI framework like UIKit, AppKit, and SwiftUI provide their own attributes in their own scopes. We can assign foreground color or underline style using SwiftUI types, and the text view will recognize these attributes and style the string accordingly. SwiftUI scope doesn't include all of the attributes from other scopes, so if it can't deal with a particular attribute, it will just ignore it. For example, paragraph style is not a SwiftUI attribute. When we assign it to the attributed string, it goes into UIKit or AppKit scope. When we use that attributed string with the SwiftUI view, the paragraph style is ignored. We can find a list of supported attributes in SwiftUI in the documentation for attribute scopes. They include background and foreground color, font, kern, and tracking, underline, etc. The SwiftUI scope also includes the foundation attributes, but only some of them are supported by text. The link and the inline presentation intent are among the ones that do get recognized by SwiftUI. Accessibility attributes are also included and supported by text. We can modify how different portions of text are treated by the accessibility technologies for a better user experience. Some of the attributes from the AppKit and UIKit scopes have equivalents in SwiftUI. And if they're present in the attributed string, the text will convert them to SwiftUI attributes internally as closely as it can, and the string will be styled taking these attributes into account. We might have AppKit or UIKit attributes if we're using multiple frameworks in the same project, or converting an NS attributed string into an attributed string. In our example, the attributed string includes kern and foreground color in the AppKit scope. When we parse the string to text, it converts those attributes internally and displays a string with the appropriate styling. So that was a lot of information about text, and I think we should go over now and review what we discussed today. So text is a SwiftUI view that is included in many built-in components. Text can be created with different data types, and it gets resolved into a string for display. It's important to choose the right initializers and to understand what they do to get consistent results with text and to diagnose issues if we encounter any. For styling separate portions of text, we can use text modifiers with text interpolation. For styling an entire text view or applying modifications to multiple text views at once, we can use view modifiers that affect text. Text integrates nicely with this attributed string APIs from Foundation, and we can choose any styles from the SwiftUI scope to be reflected in the displayed string. I hope you enjoyed the talk and maybe even learned something new. I'm happy I had a chance to talk to you today and participate in the conference, even being far away here in New Zealand. And if you want to get in touch, you can find me on Twitter, or you can check out my blog or my website as well.
Hi, can we see you at full size?
What should I do? Just stop sharing, right?
Yeah, go for it. So thank you so much. I did not know how much I did not know about text, and knowledge of your ignorance is the start of wisdom. So we're getting there. I'm sure I'll try and stop them doing my problem is in this particular case because we've got Daniel to do that on tomorrow. But any kind of general questions there for Natalia? Yes, Peter.
I am wondering how text will be rendered on screen. So will it be translated to some sort of UIKit component, or will there be like a bitmap translation process of some sort? Can you talk a little bit about that?
Did you get
that's one of the things, you know, the SwiftUI team always said, don't worry about the performance, you know, just stuff things together and, you know, use as many small screens as possible. And I'm wondering if you can share some of why we shouldn't be worrying and, you know, why it might be performant.
Did you get that, all of that?
Yeah, I did. I'm afraid I can't really share what goes on internally beyond of what I shared. I think I went like to the point I could share, but I don't think you can do much about performance on your side, to be honest. Like if you do encounter text performance issues, you have to file feedback, I'm afraid. Yeah, because I don't think you have much control over the rendering per se. from your side.
Any more brave souls? One at the back.
You mentioned environment at the start of the talk. Is that the mechanism that the modifiers use internally to pass their weights and the colours down into the children?
You didn't get that one, did you? It's a long way back.
No. Yeah. We need to repeat it.
You mentioned environment at the start of the talk. Is that the mechanism that is used to pass the modifiers down? So
yes, the text ones, yes. Like there are multiple types of modifiers in SwiftUI. Some of them pass values down, like I think all of the text, the ones that affect text probably, unless I'm missing something. But there are other types of modifiers that also send values up. For example, like something like a toolbar. When you apply like a toolbar modifier, it actually floats up and to the nearest container that can actually like display a toolbar. So there are two different mechanisms. There is the environment, which sends values down, and there are preferences, which send values up. And there are multiple modifiers that some of them use the environment, some of them use preferences, and some of them modify the target directly, like opacity, for example. It doesn't write neither, like it doesn't write a preference, it doesn't write an environment, it just like modifies the target it applies to.
Great. Thank you, you said. Any more?
If you're using hard-coded text and it's not going to be localized, should you use the initializer? Is that more performance?
I think the question was, if you're using hard-coded text and it's not going to be localized, should you use verbatim?
Yes, I think so. I don't think there should be like you would see a big performance hit if you don't, but I think it's just safer, and you know yourself that it's not supposed to be localized, and just in case something does match this localization in the future, you won't get some unexpected result that it like localizes something you actually did not intend to localize. So yes, I would say yes, prefer to use verbatim for like literals that you don't want to localize.
Okay, well, I should say we're really disappointed you didn't make it this year. We hope you will make it in future years. And
yes, me too.
I have a little present for all of the speakers, so I will get your address off you and I will send it to you in New Zealand, okay?
That's really nice. Thank you. Thank you.